Well, how's everybody doing out there? Well, welcome to day 6 of Corona Online School. And we're actually finishing up section 9.2 today, which is all about circles. And we'll briefly talk about spheres. We'll go into more spheres and three-dimensional objects later in the semester. So, really, the main part of this section is learning definitions and things related to circles. So, there's a lot of definitions on here. As you can see, I've got them a spot for you to write them down. So I am actually going to talk a little bit about some of the definitions just so we make sure we're on the same page and stuff like that. So if we look through the PowerPoint, so a circle is obviously, a collection of points in the plane that's equidistant to a given point. And so that point that's in the middle is what's called the center of the circle. And that's also how you describe the circle. So this would actually be called circle A in this case. So you always define a circle by whatever the center point is. All right. So the radius is just from the center out to the edge. And so I've tried to highlight all of these things in blue for you. So there's obviously an infinite amount of radii that you can actually draw, but I'm just kind of drawing an example of one of every type of everything. We've got our chord, which is again in blue, so it's going to be where a point on a circle connects to another point on a circle, so it doesn't necessarily have to go through the center or anything like that. And then the diameter is the longest chord, so it actually does go through the center. So we can see it joins B and D together, and it just so happens to go through the middle, so it's the diameter, so it's the longest chord. Then we've got our minor arcs. So our minor arcs are arcs that are going to be less than 180 degrees. So in this case, going from B to C would be a minor arc. Technically, C to D would also be a minor arc, but again, I'm just kind of demonstrating one. And when we talk about arcs, the symbol for it is BC with a little kind of curve over top of it. So just kind of keep that in mind. For like the chords and things like that, we're using the same old line segment definition. So this would look like BD with a little line over it. This would look like BC with a little line over it. So that notation is the same that we would use before. So the only new notation we're going to get is related to arcs. Sometimes you may actually have an arc with 3 letters just because you want to make sure you know you're going the right way. So in this case, like if we look at major arc, in this case, since it's going from B through D through C, I wouldn't want to do BC because that made me make me think I'm going this way. So since in this case I'm actually going through B, D, and C, whoops, I want to include all of them in there. So it's okay to have 3 points labeled for an arc because again, the direction could matter and things like that. So kind of keep that in mind. So a semicircle is just, a half an arc and stuff like that. And so again, you could define this using the same, like BCD with an arc. So a central angle, and we talked a little bit about this when we were talking about polygons. So the same definition is true. So the central angle is going to be an angle that has the center point of the circle as part of the angle, as the middle of the angle. So in this case, that little blue would actually be one of the central angles. So again, there's a lot of different central angles. This is just one. So an inscribed angle is going to be like if you have an angle that actually goes off of the side of the circle, not through the center. So in this case, notice kind of angle D makes an inscribed angle C makes an inscribed angle, and angle B. All those make an inscribed angle. So again, the angle is based off of the sides of the outside of the circle, not the inside. And an inscribed polygon, in this case, we got a nice little triangle on the inside. So any polygon shape that you can actually form that lives inside the circle could actually be an inscribed polygon. So there could be lots of different possibilities here. So again, you can see this in blue. And then finally, almost finally, so tangent line is a line that touches the circle at one and only one point. So in this case, if we look, I made the line kind of fat so you could see. So in this case, it just touches the circle at B. It never crosses the circle at any other point in this case. And then finally, secant line is kind of like a chord, but it just goes on and on and on forever. So again, instead of stopping at B and C, in this case, like we'd say the secant line, and we'd use like the line definition. So same thing here. Unfortunately, there's no other point on here, but if we were to add a point E, then we would call this tangent line like BE, and we'd use the line notation. So again, I just kind of went through those real quick. You know, take your time, pause the video, write these definitions and stuff down in your notes, and they'll come in handy when we're doing some of the activities. So let me go back to the classwork. So that takes us through the first 2 pages of notes. So now what we want to do is actually kind of put these definitions to work by going through and actually identifying some of the parts on a circle here. So I'll go through this example, and then I've got one for you to practice on your own at the end. So in this case, it's asking us to name 3 chords. So again, we're looking for things that, you know, aren't going through the center. So they're actually going from kind of one side to the other. So in this case, I'm just going to highlight stuff and then write them down. So like BC would be an example of a chord. CE would be an example of a chord. And ED would be an example of a chord. So let me jot those down real quick. So we've got BC, and so again we want to use our line segment notation since this doesn't go on forever. CE and DE in this case. So those are going to be, and so again, there's another chord on there, but I was kind of saving that for the next one. So some of these there may be lots of right answers. So just because I wrote down one doesn't mean it's the only right answer. So kind of keep that in mind. So now it wants us to name the longest chord. So in this case, the longest chord is always going to be the diameter. And so in this case, our diameter, so we're looking for a chord that goes through the center. So in this case, DF is a chord that goes through the center. So it's going to be our longest chord, or again, our diameter. So just to kind of keep those both in mind. All right, so now we want to name 3 radii. So again, oops, I think there's actually 4 right answers in this case. So I'll actually highlight all of them just so you can see, and then you can pick your favorite ones. So radii, remember we're starting in the center and going out to the circle. So in this case, there's actually 4 radii on the sheet. I'm just going to list 3 of them. So we've got AB, AF, and AC. So if you're doing a radii and A, in this case, since our center is A had included in all your answers, then one of those can't be a radii. So remember, the radii always starts at the center and goes out. So it should have A something in it for each and every answer. All right. So 2 and 4 are technically the same thing. So we already saw that the longest chord was DF, which I said was the diameter. So again, same thing down here. The diameter is also the longest chord. So they're interchangeable. So we've already done this guy. All right. So let me erase these little radii. So now what are we looking for? So now we're looking for an isosceles triangle. So first thing, if you've forgotten what an isosceles triangle is, so remember an isosceles triangle has 2 sides the same length. So when I look at this, first off, there's no measurements anywhere. So how in the world am I supposed to decide if something has the same length? Well, remember, the key to this is the radii of a circle always have the same length. So in this case, AB, for example, and AC, since they're both radii of the circle, have to have the same length. So luckily these guys are connected, so I can just kind of connect B and C, and that'll give me my nice isosceles triangle in this case, where AB and AC are the sides that are the same length. BC isn't the same length, but that's okay because we only need two sides the same. So in this case, I'm looking at triangle ABC. And so normally when we talk about a triangle, we always put the little triangle symbol in front, even though I didn't do such a good job with mine, but there we go. So, and to kind of piggyback off of that, name two congruent angles. So again, remember, if isosceles triangles have the same sides, then that means those angles also have to be congruent. So since, let me erase these here. Since this side and this side are congruent, then that means that this angle and this angle also have to be congruent. So those opposite angles have to be congruent. So in this case, angle ACB is going to be congruent to angle ABC. And so remember, when we write our angles, the part that we're interested in always has to go in the middle. So in this case, I kind of started with A for both of them and went to C and then out to B. And then on the other one, I started with A, went to B, and then out to C. All right, so let's see. So name a central angle. So again, this is going to have a lot of right answers. So there's a bunch of central angles that are going on here. So again, anything that's going to start off in the center is going to be a central angle. So like in this case, like that's going to be a central angle. This is going to be a central angle. This would be a central angle. And this would be a central angle. So there's actually 4 different central angles that you can choose from. So just pick one. So I'm going to pick this one just because I like that one. So in this case, we're looking at angle BAF. And so again, since angle A is the center of our angle, I have to make sure it's the center of the symbols when I write it down. All right, so now we want to name a semicircle. So let me clean this up a little bit here. So again, a semicircle is always going to run from around the diameter. So technically, there's 2 different semicircles that we can actually name here. We can go from like F to D, or we could go from D this way around to F. So that's always the cool thing. You're always going to have 2 semicircles. So again, just pick whichever one you want. Again, don't just write down DF, because that won't tell us whether I'm doing the green one or the blue one. So you do want to distinguish between which one you're picking. So, and if you did the blue route, even though there's 4 points on there, you wouldn't have to use all 4 points. If you do, it's fine, but you definitely would want to use D and F and either E and C, but you don't have to use both of them. So in this case, like, I'm just going to do the blue one since it does have the 2 points. And so I would write it as D, E, F, and then my little arc symbol over the top of it in that case. All right. So now, let's clean this up. So let's go back to name a minor arc. So in this case, again, there's going to be lots of minor arcs on there because anything that's less than 180 degrees is going to be a minor arc. So like, for example, like D to B is a minor arc. B to F would be a minor arc. F to C would be a minor arc. C to E would be a minor arc. And then, oh, let's do gray here. D to E would be a minor arc. But then also, like D to C would be a minor, like DEC would be a minor arc. BFC would be a minor. So there's, even though I drew a bunch, there's actually even more than what I've actually sketched out, because you could overlap these some and get some other minor arcs. But again, we're only interested in labeling just one of them. So I'm just going to pick, let's say C and E, for example. So in that case, my minor arc is just CE. But again, there's tons of right answers on this one. So just because I picked that one doesn't mean you can't pick something different. Let's see. So major arc. So again, a major arc, we're looking for anything that's bigger than 180 degrees. So there's going to be less of these, but there's still, a couple that you can actually do. So for example, I can go from, so I know D to F is a semicircle. So if I go from D the whole way around to B this way, that would be a major arc. And there's other ones too. So again, anything that's bigger than 180 degrees would actually work in this case, but I'm just going to leave it at that. So in this case, I'm looking at DFB. And then my little arc symbol. All right, so in this case, so last thing, let me erase this real quick and then we'll go read what we've got to do. So what 2 points on the circle could you connect to form an inscribed quadrilateral? So again, what we're looking for is a four-sided figure that lives inside the circle. So we want to draw in the line segment and then name the 2 points and then what kind of quadrilateral is it? So if we look, we saw we had an inscribed triangle in there. And so now be careful, like you might look at this and say, well, heck, there's an inscribed quadrilateral and I didn't even have to add any, lines or anything. But remember, an inscribed means that all 4 points have to live on the circle itself. So in this case, this point here is inside the circle, so it doesn't count as being an inscribed quadrilateral in this case. So that guy doesn't actually count. So in this case, that orange figure that I drew, even though it's technically four-sided, it's not considered an inscribed quadrilateral or inscribed polygon. So we need to actually make it so all 4 points are on the circle itself. So with that in mind, I kind of see that I've got 4 nice points here. So if I think of this one, this one, this one, and this one, that's given me the makings of a nice quadrilateral. So if I just connected B to D, so I've already got D to E connected, E to C, and B to C connected. So, and there's a nice four-sided figure. All 4 points are on the circle. So I'm going to go with that one. So in this case, I had to connect B and D. And what kind of shape do we have? Well, it looks like a trapezoid to me. So I would say trapezoid. All right. So again, if that makes sense, let me, or if it doesn't make sense, let me know. I mean, if it makes sense, you can let me know too, that's fine. But if it doesn't make sense, definitely let me know, ask me questions or anything like that. So otherwise, let's talk quickly about spheres. So again, this really isn't the focus of this section. Three-dimensional stuff's coming later. But just like a circle is, there's a center point and all the points are equidistant from that center. Same thing's true of a sphere. So with a sphere, we've got a nice center point of A, and then all the points that form the sphere are the same distance away. So in this case, and I've drawn an example of 1 radii in this case, so point P lives on the outside of the sphere. And so again, just like a circle, a sphere has radii and things like that. And so what are some real life objects that are the shape of a sphere? Well, we could, yell stuff out all day long, like any kind of, except for a football, like basketballs, soccer balls, golf balls, baseballs, all those are spherical in shape. Planet Earth is spherical in shape. So all kinds of things are sphere shaped. So you can jot down anything that you want. And then, since Earth is a sphere, sometimes they'll call the circumference of our planet the Great Circle. And so where would this Great Circle be? So if you notice, it's kind of the gray that's drawn in here. So what do we call that circle that actually goes around the middle? It's really hot there. So yeah, so this is would be the equator of the globe in that case. All right, so again, we'll go into a lot more details about spheres and stuff like that later. So for right now, I just wanted to kind of briefly introduce the definition so you were thinking about it. So at the very end, here's a nice practice problem for you to work on. So again, it's very similar to the one we did together. So if you get stuck on it or have any questions about it or anything like that, feel free to let me know. Otherwise, have a great day and good luck finishing up 9.2.